Hey everybody, I'm Yerosen Assegid, and I'm a software engineering student of third year, and also I'm gonna explain all things about this student academic record management system. It contains this first one page. I just explained almost everything about this student academic record management system that built by those five students. And first, we see research from its introduction. And as this introduction is contains different things, overview of this project, background of student result management. What's the background of student result management? Okay, let's see. Student result management is a fundamental activity in educational institution. We know this one. Used to organize, store, and evaluate students' academic performance. Traditionally, many schools rely on manual system. We know, like paper system, to storing different values or different marks of students. But this website is just prepared for those manual systems like a spreadsheet to manage student data, subject information, the examination results. This method will lead to inefficiency, including data redundancy, including such difficulty in generating reports. Even to pick one value of student or one markers of students from those different uh, huge or vast amount of students secured. So it gets difficult and it gets vulnerable for data redundancy in the consistency of data. No, with advancement of database technology, educational institution can adopt traditional database system to manage academic records more efficiently. Mm, More efficiently, a database-driven system allows structured storage of students, subject, and marked data weight supporting automated competition such as total scores average, ranking, pass, fail, status. The project implements the student academic record management system as web-based application integrated with MySQL relational database. Okay, let's see overview of it because we don't have time. Just I don't want to do the link out my time on this introduction. Let's get into problem statements. Many educational students here face challenges when managing the student academic records using manually or fully structured system. These challenges include different problems. Those one is let's pick one of them. Difficulty in maintaining a student record in centralized system. Within centralized system, it's just difficult to store different values of students based on manually when we try to take points or markers of students now. And the other one is repetition of data entry. We just talked about this one on data redundancy and consistency of uh, and that is just we store manually, other than this kind of system. And the another one is repetition of data entry for subject teachers and departments. We know this one is also one of the problems that we got when we try to store data of students. And the other one is importance of the system. Student academic record management system important for the following reasons. From those reasons, let's talk about one of them. It centralizes academic data into structured and reliable database, and it reduces human errors in math calculation and the report preparation. And let's jump into requirement analysis in case of time. Now, independent problem analysis after analyzing the real-world scenario of students. Okay, the another one is educational institution requires centralized system to manage student academic data instead of relying on scattered records such as paper files or spreadsheet. When you see manual records management system, it just keep our data within like scattered system, based on paper. So it just changes these two, like uh, um, something system like it's not difficult to get some data of students, and the different systems user require different permission. Like admin, the subject teacher, and the own teacher, they have different own function. So from this function, the first one is at admin. It have money system data like student, teacher, subject, department over all management system of its own, and as another one is subject teacher records and update markers. Homeroom teacher it just reviews reports for assigned classes. And another one is functional requirement. The system must support the following functional requirements. The first one is application access control, like login and logouts for those three interfaces. And three users, admin, subject teacher, and the homeroom teacher, they have their own login and logouts permission or authentication system. The another one is student management. Student management is also contain this student management system. And the another one is department management system, and the other one is subject management, teacher management, mark management, report generation, management. This all functional requirement is contained within the system now. The another one is business rules. The following business rules are enforced in the system. And each department name must be unique. Subject name is also unique, and each user must have a unique username. And that's another one. Each subject has a fixed total mark of 100. And then another one is a mark must be within a range of 0 to 100. And also contain different kind of student can have only 1 mark per subject. This all business rules what we see here. And the other one is grade operation analysis. Okay, create, read, update, delete. It contains all of these operations. This operation is contained within this system of SQL. Okay, key design decision the justification. Okay, this is the first one is ranking method. System used to reduce ranking based on total marks and describing order. For example, to pass, to fail, and everything is contained here. Student E 450 rank 1. Student B 450 rank 1. For ranking system now, the person who get more mark, it just it just gave the first order from other students now by the below uh, its value or mark that is carried. And another one is possible determination. The system used two levels, subject level over all results. For passive fail, mark is greater or equal to 50. Just one is pass. Mark less than 50 is fail. Another one is over all results. Now student must have all marks in the total greater or equal 50% of total possible pass, otherwise fail. Now another one is system design. Entity relation diagram, entities, attribute relationship. This you can see from our videos that's recorded by other student because this is role of other students. I don't have to link my time here. I just want to pass to the other. Okay, this is also entity diagram designs. Uh, Here's entity description for admins for class departments, students, teachers, subject is markers. There is also attributes. Student is subject is markers. They are primary key, foreign key also. For primary key we use mark ID, student ID. They have their own primary key and foreign key as we see. Okay. The another one is relationships. What the relationships of admin, department, teacher, student, one to many or many to one. This talked about all things you can see from the documentation here. Okay. The another one is design justification. The system design follows proper data design principle. You can see here separation of entity, markers, stories, paritable, foreign key relationship, dynamic subject design, role-based structure. Also there is database design. I don't have to waste my time here. There is a foreign key. There is primary key constraints. What constraint means? Constraint means a limitation of accessibility or something. For example, maybe there is a primary key, unique now, known now. These all are constraints that we should contain it on our SQL codes. The another one is referential integrity constraint, domain constraint, uniqueness constraint. Those all are types of constraint. Now business rules, non-null constraint, and another one is normalization. This normalization up to certain normal forms. Now, first normal form, transformer table. First, let's see about the database detail follows normalization principle to eliminate redundancy and improve efficiency. Okay, thus is what normalization can work on it. Another one is implementation. You can see from our video, this is implementation. It means just code of SQL that we use on our system. Uh,
እሺ ስሜ ያው ተስፋሁን ብርሃኑ እባላለሁ። የሶፍትዌር ኢንጂነሪንግ ሶስተኛ ዓመት ሴክሽን ኤ ተማሪ ነኝ። ዛሬ የኛ ፕሮጀክት በትንሹ ለማስረዳት ሞክራለሁ። እሱም የኔ ድርሻ የነበረው የዩዘር ኢንተርፌስ ነበረ ዲዛይኑ እና ዩአይ ነው። እንደምናየው እዚህ ጋር ዩአይ አለ። የሲስተማችን ስም ስቱደንት አካዳሚክ ማናጅመንት ሲስተም ነው። ያ ማለት አሁን ብዙ ፊቸር አለው። በእርግጥ ዩዘሮቹ አሁን በአድሚን እንግባና የእሱ ኢንተርፌሱን ዳሽቦርዱን የአድሚኑ ዩዘር ኔም አድሚን ይላል። የእሱ ፓስወርድ ደግሞ አድሚን 123 ነው። ይሄ የአድሚኑ ዳሽቦርድ ነው። የአድሚኑ ዳሽቦርድ ሲሆን አክቹዋሊ እዚህ ጋር ዩዘር ኢንተርፌስ ዲዛይን ለማድረግ ዲፕሊ የተጠቀምኩት ቴክኖሎጂ ሪያክት እና ቴልዊንድ ሲኤስኤስ ነው እና አኒሜትድ የሆነ ፔጅ ነው። እንደምናየው አኒሜትድ የሆነው ነው። በ0.35 ትራንዚሽን ነው የተሰራው። ሶሪ እና ይሄ የአድሚኑ ዳሽቦርድ ነው። በአድሚኑ ዳሽቦርድ ላይ 4 የሚሆኑ ወሳኝ ነገሮች አሉ፣ ወሳኝ አክቲቪቲዎች አሉ ወይም ፔጆች አሉ። ከነሱ ውስጥ ክላስ፣ ስቱደንት እና ሳብጀክት እና ቲቸር ናቸው። እነኚህ በዳታቤዝ ላይ የየራሳቸው ቴብል አላቸው። ክላስም፣ ስቱደንትም፣ ሳብጀክትም፣ ቲቸርም የራሱ ሪከርድ የሚደረግ ዳታ ስላለ ለእነኚህ ለአራቶቹ የየራሱ ቴብል አለ። አሁን ለክላስ፣ ለስቱደንት፣ ለሳብጀክት እና ለቲቸር ደግሞ አራቱም እርስ በርስ የተገናኙ ናቸው። ምክንያቱም እኛ የምንጠቀመው ሪሌሽናል ዳታቤዝ ነው እና ክላስ አለ፣ ስቱደንት አለ፣ ሳብጀክት እና ቲቸር። ክላስ ለተማሪ አስፈላጊ ነው። ስቱደንት ደግሞ የራሱ ሰብጀክትም አለው። ቲቸርም ደግሞ የሚያስተምረው ተማሪ የራሱ ተለይቶ ነው የሚቀመጠው። ሳብጀክቱም ተለይቶ፣ ክላስም ተለይቶ ነው እና ወደ ክላስ ፔጅ ስንገባ ክላሱን እዚህ ጋር አድሚን አድ ያደርጋል። ከፈለገ ክላሱን አድ ያደርጋል። ክላሱን ደግሞ ኤዲትም ያደርጋል፣ ዲሌት ያደርጋል። እነኚህ በክላስ ውስጥ ያሉ አክቲቪቲዎች ናቸው። አድሚኑ ማድረግ የሚችለው አክቲቪቲ ናቸው። እነኚህ ክላስ ከዚህ በፊት የተሰሩ ክላሶች አሉ ማለት ክሬት የተደረጉ እነኚህ ፖፕአፕ የሆኑ ክላሶች ናቸው። የክላሱን ዲስክሪፕሽን አስፈላጊ ከሆነ ይጻፋል እና ይሄ አጠቃላይ የክላስ ፔጅ ነው። ስቱደንቱ ጋር ስንመጣ ደግሞ እንደዛ ነው። ልክ ስቱደንቱ አድ ይደረጋል፣ ኤዲትም ዲሌትም እነኚህ ወሳኝ አክቲቪቲዎች ናቸው እና ክላሱ ስቱደንቱ የራሱን ክላስ አሳይን ለአንድ ተማሪ ይደረጋል። ለአካዳሚክ ይሩ ስቱደንት የሆነ የራሱ ሴመስተርም አለው እና አክሽኖቹ እንደዚህ ናቸው። እነዚህ ናቸው። ዲሌትም ኤዲትም ይደረጋሉ። ተማሪም አድ ይደረጋል። አድ ሲደረግ የራሱ ስም አለው፣ ጾታ አለው፣ እነኚህ አሉ። ፖፕአፕ ያደርጋል ሁሉ እነኚህ ኦልሬዲ ክሬት የተደረጉ ክላሶች ናቸው። አካዳሚክ ይርም እንደዚህ፣ ሴመስተሩም እንደዚህ ሴቭም ይደረጋል እዚህ ጋር። ሁሉም ነገር ፋንክሽናሊቲ አሪፍ ነው እና ሳብጀክት ወደሚለው ፔጅ በምንመጣበት ሰዓት ሳብጀክቱ የራሱ ዲፓርትመንት አለው። ሳብጀክት ዲፓርትመንት፣ በዲፓርትመንቱ ስር ደግሞ ሳብጀክት አለ። ዲፓርትመንቱ ለምሳሌ ኮምፒውተር ሳይንስ የሚል ከሆነ በኮምፒውተር ሳይንስ ውስጥ ያሉ ሳብጀክቶች ሲ ፕላስ ፕላስ የሚባሉ፣ ፓይተን የሚባሉ እነኚህ ኮርሶች ማለት ነው ይደረጋሉ። ፋንክሽናሊቲ ይሰራሉ ኮርሶችን። እነኚህ ዲፓርትመንት የምንላቸው ሳብጀክትም ኤዲት የሚደረጉ ነገር ናቸው እና አሰሆል ይሄ እንደዚህ ይመስላል። ይሄ የቲቸር ነው። ቲቸርም አድም ድሌትም ሁሉንም ነገር ይሰራል። እንደገና ደግሞ በመምህራን እንግባና ሆም ቲቸር በተለምዶ ልሰንጠር የምንለው ሆም ቲቸር የምንላቸው አሉ። አሁን እንደ ሆም ቲቸር እንግባና ለምሳሌ አበበ የሚባል ሆም ቲቸር ከዚህ በፊት ተሰይሟል። አበበ የሚባል ፓስዋርድ እስከ 4 ነው። እሱ አሁን በምንገባበት ሰዓት የራሱ የሚያስተምራቸው ተማሪዎች ዝርዝር እዚህ ጋር ያገኛል። የራሱ የሆነ ውጤቱን አስተማሪው አሁን ተስፋውን ለሚባል ተማሪ የማትስ ውጤት ገብቶለታል። የማትስ አስተማሪ ነው የሚያስገባው እንደ አስተማሪ እና ውጤቱ ይሄ ይመስላል። እሺ ይሄ የሆም ቲቸር ነው ወይም በተለምዶ ስንጠር ብለን የምንጠራው እንትን ነው። አሁን ደግሞ ሎጋውት እናድርግና አሁንም ሌላ አሁን ኖርማል ሜምበር አለ ኖርማል ሜምበር አለ። እሱ ምን ያደርጋል? ያስተምራል፣ ውጤቱን የእሱ ይመዘገባል፣ ሁሉንም ነገር ሪፖርት የሚያደርገው እሱ ነው። እና እሱን አሁን ጊዜ ብለን እንግባ እስኪ። ለምሳሌ ከዚህ በፊት ስላለ ማለት ነው። ፓስወርዱም ቲቸር ዋን ቱ ስሪ ሶሪ ጊዜ ፓስወርዱ ቲቸር ጊዜ እዚህ ጋር ገብቷል። ያው የራሱን የሚያስተምረው ተማሪ ማርኩን እዚህ ጋር ማስገባት ይችላል። አስሆል ሲስተሙን ይህን ይመስላል ካለን ጊዜ አንጻር ነው። አመሰግናለሁ።
Okay, how are you? My name is Yonas Debelo. Let's start presenting my contribution in our database system project. My contribution for this project was serving as a database designer and a system analyst. I acted as the system analyst to ensure our database was structurally good or sound before any code is written. Over a few minutes, I am going to walk you through what my 4 major contributions was. So let's start from introduction and the project goal. Before I walk through the structural blueprint of our database, I want to briefly explain exactly what we have tried to solve. Traditionally, schools manage students' data using scattered spreadsheets or paper records. This leads to massive data redundancy and makes generating end-of-semester reports incredibly time consuming. So we was based on these problems in real world scenario. We tried to solve these traditional problems. So we have identified entities and attributes based on the real world scenarios, such as the high school that we see around our environment. For example, the teacher are usually hired for a specific department like science or maths, but they rarely teach just one single class all day. For example, a science teacher might teach biology to the ninth grades in the morning, and he may teach different subjects in the afternoon, maybe grade, we can say grade 10. So this means the teacher can uh, assign to many subjects in real world scenario. So we have taken the teachers as the one entity, the department is the student, the subject is the classes as the entity, and the attributes such as years, semesters, and such as based on what we see from our around the schools around us. Then the second one is the system relationship and the design justification. When we see the section 6.4 and the 60.5 from our document of the project, the relationship and our design justification, it establishes the basic one-to-many relationship and the many-to-many relationship. The one-to-many relationship is simple, but for example, one department manages many teachers and related others. There are many one-to-many relationships, but when we come to many-to-many relationships, that is the difficult part. We can't simply implement that in our database. So for example, a student may take many courses, and many courses have taken by many students. This is the one-to-one, the many-to-many relationship. We cannot just simply go around or simply implement this in our database. So we need to creates the junction or the bridge between them that connects these two classes or these two entities. We set the associative entity or the junction table. For example, the marks table act as an associative entity between students and the subjects that by using this we can simply implement the many-to-many relationship that is different from one-to-many relationship. So the marks table is the junction between them and it uses the foreign key of both the subjects and the students for primary key as the foreign key. The second one is the case and the data integrity constraints. Our database is based on how it's structured and how it is secured. Even if we structurally implemented our database well and not guaranteed the database security, that is useless. We must implement the security of our database. So we use the defense in depth. We didn't directly depend only on the front end, even if the front end can validate the data. So we also implemented how our database validates the data by itself without solely depending on the front end of the website only. And the other part is the normalization strategy. This means we must implement our normalization strategy to enforce our feature scale up and such. The first one is the first normal form. We ensure all attributes were atomic and eliminated repeating groups. There is no repeating groups and all attributes should be atomic. For example, a student doesn't have a single column containing a list of all their grades. If there is such kind of repeated groups, that shows there is no normal form we have implemented. So by eliminating this, we have ensured that our first normal form. And the second one is the second normal form. By eliminating partial dependency, we ensure that all non-key attributes depend on the whole primary key, which is why entities like students and the admins are completely independent tables. Finally, the master stroke of our design, the third normal form. To achieve this, we have to eliminate transitive dependencies as the theoretical definition of our third normal form explained. For example, the department name if the department name directly stored inside subject table, then school renames science renames the science department. We would have to run a massive SQL query to update dozens of individual subjects. If one fails, our database becomes corrupted. By separating departments into its own isolated table and linking it via a foreign key, we only have to update the name in exactly one place. So this is how we have implemented our search normal form by eliminating such kinds. So this we ensure all normalization strategy as completely implemented in our project. So thank you for attending my presentation. I've finished.
Hi, Mr. My name is Mr. Ahmed, and I'm with my team is SQL developer, and my ID is 1815. And as a SQL developer, I have created those database schema for the student academic result management system, and also creates enumeration types, lookup tables, main entity tables like departments, admins, students, teachers, subjects, and marks. And also constraints are there, indexes, and any triggers required by the application,
and also to run the database once a new database before loading sample data or applying migration. And also I use the PostgreSQL. This is database management system good for me and simple for me. And also I've created the database should be created separately. And when we directly go to the implementation, creation of an enumeration, we have create two enumeration types, gender name, gender enumeration, and teacher role enumeration. Under gender, there is a male, female, and others enumeration, and also under the role, from teacher and subject teacher. When we look up the tables, also I have created up to third normal form of normalization database under the department tables. The only we have in this department tables, department ID attribution is a department ID, and department names. Department names should be unique, and also the other tables admin. We create obsession-based authentication for the admin tables and have those uh, attributes, admin ID, username, and hash password. The other is tables are student tables. The student tables have those attributes with constraint, and the other script for creation of teachers tables are this with these attributes. Under teachers attributes, we have homeroom classes attributes. Those homeroom classes assigned to the class for the teachers, homeroom teacher. Those we use those script, and also we have constraint under this teachers table. Username is a unique, and also homeroom class is a unique. The other is checking for homeroom class, and also we have foreign key under teachers tables, which is a department ID for assigning the department to the teachers, and also we have cascade keywords. When we delete a department teachers from teachers and also deleted from here, and the other we created is an index for fast query retrieval on the teachers with the department teachers department. Mm, the other tables we have in the subject tables have those attributes, subject ID and subject name, department ID, which is foreign key, it's not null, and also teacher ID for assigning the subject to the teacher, and start year also total marks for this subject, which is a default to 100, and the other constraint is foreign key, which is department, and this department ID. Also, we have created index on subject departments and subject teachers. The other tables we have is mark tables. Mark tables have those attributes, which is mark ID, student ID, subject ID, teacher ID, and the marks, and also created and updated timestamp, which the marks are created, and we have updated cascade and delete cascade when one deletes, and the others also the relation with these tables are deleted, and when we update also delete for those tables, the relation between two tables are updated automatically. The others we create is an index for those three tables above the three tables: a mark student, mark subject, and mark teachers. The others we have to create is a trigger function for updated at the timestamp for each tables. We use those function update at a column. These all are triggers script for event occurs, we updated each using triggers terms. The other thing is migration. The migration script to add the start here column to the subject table and add check constraint, ensuring valid values. We create those scripts for migration to the tables. This is migration. Uh,
My name is Yerosen Girma, ID 2710, phone number 0972467962. My role is team leader, and I'm working with lead the team and assign each role for each member of the teams. Wondwosen is documentation lead, Yonas Debelo is database designer, Tesfahun Berhanu is UI designer, and Lamesa is SQL developer. And show you overall of the system focus on the functionality of the system. This is the login page of our system. There are three login page: admin, teacher, and homeroom teacher. This is let login by admin, and I will show you all the function or the role of admin. Here is the interface. There is different interface under admin dashboard. This is admin dashboard. Admin can update, delete, register subject, department, students, or others. This is a class. Admin can delete or edit the class. If is admin add class grade 12a, this is already exist, so I'll change this. See, okay, this also exists. Okay. 12d. Okay, saved, because there is no registered two class by the same name. This is how we can register student. Here is what I'm registered now, class, and I'm also registered student as act as admin. You can add a student name, Tola, male, and with his grade 12 or 11, D, year of the student attend, and with semester. This is all data of a student must fill to register, and this is subject. Subject means department with subject. I'm at Afan Oromo department. Here already added. This means the scalability of the system. Biology, chemistry, physics, below this is already existed before. When I'm add another department, so the system is scalable. And under here add subject, under which department. Maybe under department teacher is not assigned before. I'm assigned teacher next. This is the year of that department started. Saved. Here is department is saved. I can delete the department. Already the function is work. Already deleted. Here I found wrong. Department is deleted. So This is the function of our system that admin can do. Here is a teacher. Teacher, we can add teacher here. Username, Yon, password, password something. Which department? Well, maybe software. Tutor is as a teacher, subject and homeroom teacher. Select homeroom teacher for class grade 9A. Save. Already saved. The teacher is already saved. Yon, username Yon, software department, under class 9A with subject homeroom teacher. This is the work of admin. Admin also not only this can view the mark of the student is here, and overall of the system is generates pass and fail, or the last report of each individual of the system. Here is the admin can do this one, and I show you another before I going to there. Here is a teacher. Teacher is homeroom teacher and admin teacher. Here the role of teacher is right here. So this teacher is login as his login page, or as admin, as homeroom teacher, or as subject teacher. So I will show you next these two things. Let login as subject teacher. Let login as subject teacher. Tola is subject teacher that assigned by admin. Here Tola is here. This is grade. Tola, there is no Tola. Teach this grade with this. Okay, I'm changed the semester. Okay, Tola is teach this student is for second semester and grade 10, and enter the mark. Okay, if you less enter the mark less than 50, the student is fail, and more than greater than 50, a student is pass. Here the functionality of the system is working this ways. When I saved, the system is already saved the mark of this student is under enter mark of the interface of this each teacher, and I will show you the homeroom teacher. Let login by homeroom teacher that assigned by admin before. Here is homeroom teacher when he is homeroom teacher for grade 9 10A year 2018 semester 2. So here this is only mark. This dashboard of teacher is mark with pass or fail. Average rank of student is here compiled automatically. Here is the report of teacher, student, or individual student. Here is student is Wondwosen Assegid. Here is the mark. He is pass with all of his rank is. Let select another student. Ayantu. Okay, Ayantu for each student. Mark is let. If we want, we can print. The homeroom teacher can print this mark for the student is. If we want here in this ways, we can print this student report, and the overall of the system is this ways. The function of our system is working this ways. Thank you for your attention.